Okay, last time we learned how to multiply intervals whose products goes up, the products go up to a seventh, or rather we have learned to calculate the multiples of the ones that aren't augmented or diminished. Remember the table, you remember the table with the products and the rules we derived from it. If you didn't memorize it, you are in big trouble. You will be damned for eternity, and even St. Joseph won't be able to save you. Or maybe I read that wrong. Whatever. How do we compute the multiple of an interval that is augmented or diminished? That's what we're going to explore in this video. These are the rules we came up with last time for the table, if you remember. And here are some examples using the rules. Okay, now let's talk about even numbers. You know what those are, or should we call for help? We all know what those are. An even number can be written 2 times n for some number n. An odd number can be written 2 times n plus 1 for some number n. For example, 50 is equal to 2 times 25, and the n in this case is 25. It's just a letter we use to represent the number, And 25 is equal to 24 plus 1, which is, so it's equal to an even number plus 1, and the even number is 2 times 12 plus 1, and n is 12. And 49 is equal to 48 plus 1, which is 2 times 24 plus 1, and n is 24. And 100 is equal to 2 times 50, and here our n is 50. And we can use this knowledge to multiply minor seconds, Remember from the properties video, that a diminish eighth, a is an interval, equals the eighth interval minus the minor second. So the minor second is equal to the difference between the, for instance, a second, second minus the minor second. So the second is equal to the second plus the second, which means that a second is double a second. The major second is double a minor second. Duh! 2 half steps make a whole step. You could have read that off the piano, 2 half steps make a whole step. It's something everybody knows. So the minor second times 2n, n is some number, any number, is equal to the minor second times 2 times n, and the minor second times 2. Remember, 2 minor seconds make a major second, so we get that the minor second times 2n is equal to the major second times n. It's a bit like if you know that 12 times 2 is 24, and we know that 6 times 2, 6 times 2 is 12. 12 is double 6, and since you need to multiply 12 times 2 to get 24, then you'll have to multiply 6 times 4 to get 24, because it's half of it. And so a minor second times 2n is equal to a second times n. You can distribute, that means you get to multiply each part of the sum. So a minor second times 2n plus 1, remember that's an odd number. It can be written 2n plus 1. A minor second times 2n plus 1 is equal to a minor second times 2n plus a minor second times 1. And we know that a minor second times 2n is equal to a second times n plus the minor second. And remember that when you add a minor second to an interval, you're augmenting it. You remember that? So a minor second times 2n plus 1 is equal to an augmented second times n. So the only difference here is that, you're augmenting at the end, So, that's a bunch of talk. When we go through examples, it's much clearer. What is a minor second times 8? We write 8, as we just did, as 8 times 2 equals 2 times 4. 8 equals 2 times 4, so n is 4. So a minor second times 8 is equal to a second times 4, And we just use the rule that we, like for, for the, when we don't care about chromaticism. When we don't care about the chromaticism, so it's, a second times 4 is equal to 2 times 4 minus 3, which is a fifth, Since the multiple of a strong interval is a strong or augmented weak interval, we need to augment that. So we get minor second times 8 is equal to augmented fifth. And what is a minor second times 17? We rewrite 17 as 8 times 2 plus 1. And n here is 8. So a minor second times 17 is an augmented second times 8. So it's augmented 2 times 8 minus 7, which is an augmented ninth. And how do we handle any interval that is altered? Do we ask it to go away? Maybe that's how we do it. First, remember that a diminished eighth is equal to an eighth minus a minor second. So an augmented eighth is equal to an eighth plus a minor second. Properties video. And a diminished eighth times m is some number, is equal to an eighth times minus the minor second. By definition, if you're multiplying times n is equal to an eighth times m minus the minor second times m. Remember the algebra, you just distribute the thing, and you get a minor eighth, a diminished eighth times m is equal to eighth times m minus a minor second times m. You distribute it. Of course, we can get into more detail, and remember, we'll soon do examples that will make this, what we mean clear here, Okay, so if you have m equals 2n, that is, if it's even, then the diminished eighth times m is equal to a diminished eighth times 2n, which is an eighth minus a minor second, times 2n, which is an eighth times 2n minus the second times n. If m equals 2n plus 1, which would mean it is odd, then a minor eighth, a diminished eighth times 2n plus 1 is equal to an eighth times minus the minor second times 2n plus 1, which is equal to the eighth times 2n plus 1 minus the minor second times 2n plus 1, which is equal to an eighth times 2n plus 1 minus the second times n, which is minus, you can go through the algebra, and you don't have to memorize, Just distribute the number to the interval and to the minor second we are subtracting from it, or adding when we do for the augmented intervals, and just follow what we just learned for the multiplication of minor seconds. Similarly, for the augmented intervals, just proceed similarly. We get the augmented eighth times m is equal to eighth times n plus a minor second times n. M is any number. And when we go into detail, that means considering m is even or odd, we get eighth times 2n is plus a second times n if m is equal to 2n, which would mean it is even, And we get that, it's equal to eighth times 2n plus 1 minus the augmented second times n if m is equal to 2n plus 1, which means it's odd. You can get through all this and to see how we got the result, but, you don't have to remember all that stuff. You just, it's very simple. You rewrite the number you're multiplying the augmented or diminished interval by in the form 2n plus 1. 2n or 2n plus 1, depending on whether it is even or odd. And then you apply the appropriate modifier rules. Or if you just remember how to handle minor seconds being multiplied, just multiplying it all out, remember that when you diminish an interval, you're subtracting a minor second. And when you're augmenting one, you are adding a minor second. There really isn't any more to it than that. Now let's do some examples while we're still alive, before we die. This is a augmented third, times 2 is equal to augmented third times 2 plus the minor second times 2. You distribute it, which is equal to 3 times 2 minus 1 plus the second, which is a fifth plus a second. Do we have to augment the fifth? Can we leave it like that? Remember, 2 equals 2 plus 2 times 1 is even, so, that's what we just did. So a third times 2 is equal to a fifth. It's a multiple of a strong, so it has to be a strong or augmented weak. Since we got a fifth, it's a weak interval, we have to augment it. So augmented third times 2 is equal to augmented fifth plus a second, which is augmented fifth plus second, which is going to be augmented 5 plus 1, which is augmented sixth. Do we have to further augment it? We got a weak interval. We added 2 intervals of different types, so we don't have to modify anything. We just added, the fifth and the second. We don't have to modify anything. We get the sixth, so we just, we already had the augmented. That's why we keep it. So an augmented third times 2 is equal to, an augmented sixth. And remember that an augmented third is just a fourth. And remember, a fourth times 2 is equal to an augmented sixth, which is also a diminished seventh on the piano, of course. A second times 5 now, the second example. Second times 5 is equal to 2 times 5 minus 4, which is a sixth. It's a multiple of a strong, so it has to be strong or augmented weak, so we have to augment it. So a second times 5 is equal to an augmented sixth. A fifth times, now we're doing, a fifth times 2. A fifth times 2 is equal to 5 minus 2 minus 1, which is a ninth, but we can't handle that right now. It's too big. We'll learn how to handle such intervals in the next video. Next time we will wrap up with a video where we will combine this knowledge with what we learned last time about products up to a seventh to calculate any product of intervals where we cannot, where we actually care about chromaticism. And as usual, please like and subscribe, and see you next time.